All right, hi guys. This is going to be TX Algebra 2 5B. Basically, students are expected to formulate exponential and logarithmic equations that model real-world situations, including exponential relationships written in recursive notation. Okay, here we're going to focus on still writing out exponential equations that model real-world situations. Okay, for the most part, it's going to be about money, which is a bit more applied, and how it relates to like actual banking and maybe like actual debt. Let's go ahead and start off with this. Okay, so you have compound interest involving finances. Okay, all right. So this is another type of exponential equation. Consider an initial amount of money A deposited into an account that pays interest at an annual rate R, expressed as a decimal. Okay, so R is going to be your percentage, but if you have a percentage, you want to divide by 100 to get the actual decimal version of it, which is compounded n times per year. Okay, the amount of money that the account has after t years is given by this equation. Okay, so we have y, our final value, equals to a times 1 plus r divided by n. Okay, remember to make sure that you divide by 100 to get that r, and n is actually usually going to be given to you by the problem. And then you want to raise this to the power of n times t. Okay, let me go ahead and label this first. So this is our final value. Okay, so what this means is that this is going to be the amount of money that you're going to have at the end of a certain time period, whatever you're looking for. A is the initial value. Okay, this is what you had to begin with, what you put in at the beginning, or however much you had at the beginning. R is your interest rate. Divided by 100. It's always divided by 100. Never do anything other than that. Okay, and n is the number of times that the money grows in a year. Oops. Let's see. Number of times that money grows in a year. Okay. T is going to be the number of years that you want to do this for. Okay. All right. So with all this labeled, let's go ahead and look at what you would probably want to know about. Oh, here's some extra information. Sorry. Okay. So what do I mean by compounded n times a year? Okay. Basically, it means that the money increases n times a year. Okay, building up on the new balance every time. Okay, so just like the other exponential functions, basically, your money is going to grow. Like let's say you start off with $100, and then after 1 month it becomes $101. Well, after 1 month, it became more money. So after another month, you're gonna end up adding more interest because you base your interest off of percentage of the amount that you currently have in your bank account. Okay, so you're not always going to gain $1. You're going to keep increasing that value until basically you finish. You take out your money. I mean, although you're given a number, for your interest rate, the value will not be the same as the one that you expect. Okay, so they might tell you it's 5% annual interest rate. It's probably not going to be 5%. Okay. They might tell you like 24%. It's not going to be 24% either. Okay. Usually these values are there to, I don't know. I want to say it's confuse people, because there's really no reason why, or at least in my opinion, there's no really real reason why people should give you different values. When the math is easier, they give you the simple value. Okay. Now, okay. This idea is essential whenever you look at paying off a house or a new car, or when putting away money for college or retirement. Okay, the same thing. You could pay off college instead, whatever. Okay, basically you're adding interest, so your money is growing in some way, or your debt is growing in some way. Okay, up until you finish paying it off, it's going to keep growing. Okay, we're not going to have problems if we're going to pay off a house or something like that for this. I'm going to keep it simple for now, but later on we are going to be looking at problems that are a little bit different. Okay, example problem. Okay, so let's say you deposit $4,000 into an account that pays 2.92% annual interest rate. Okay, you want to find the balance after 1 year if the interest rate is compounded quarterly. For this problem, you want to highlight a few things, or at least underline a few things. Okay. First of all, how much money did you start off with? Well, if it says you deposit $4,000 into an account, that's how much you started off with. Okay, that's the amount of money that you put into the account at the very beginning. Okay, it pays an annual interest rate of 2.92%. That percentage, that's usually going to be your interest rate. It's usually going to be really important towards the problem. It says 1 year. Okay, that's pretty important. Then the amount of time that you want to do this for, especially if it tells you years. And then it says if the interest rate is compounded quarterly. Quarterly actually means, let me go ahead and write this down. This means 4 times a year. Okay. This means that your money is going to be growing 4 times a year. Okay. If you look back, that's what your end value is going to be, 4 in this case. Okay. So you deposit $4,000 into an account that pays 2.92% annual interest rate. Find the balance after 1 year if the interest rate is compounded quarterly. Okay. So if it compounds 4 times a year. Okay. So well, we're going to go ahead and look at the equation again. We have a times 1 plus r divided by n to the power of n times t. Okay, a is $4,000. Okay, that's our initial value. That's how much money we started off with. Inside of the parentheses, you're always going to have 1 plus or 1 minus, depending on whether the value is increasing or decreasing. In this case, you're increasing, obviously. And we're going to have r divided by n. Okay, well, r is 2.92%. Since we want to turn that percentage into a decimal, we got to divide by 100. This is going to give us 0.0292. I'm going to write that down right here. And we want to divide this value by the number of times it compounds in a year. If it says quarterly, we divide by 4. Okay, basically, oh, that shouldn't be a t. Okay, and then we multiply that 4 times the number of years that we want to do this for. Since we only want to do this for 1 year, we multiply times 1. Okay, then you want to simplify anything inside of the parentheses. 4,000 stays the same. 1 plus 0.0292 divided by 4. I'm going to go ahead and add those values up. Let me use my calculator real quick. 1 plus 0.0292 divided by 4. Let me know if you guys are having trouble doing this, by the way, with a calculator. If you need one, I can show you guys what are some good websites for it if you need to use an app. For the most part, most of these problems can be done with a regular scientific calculator. I'm sorry that you don't have a TI-8084 calculator at the moment, but if you download it at the beginning of the year, you're always welcome to use your laptop for it. Okay, and we raise this to power 4. Okay, so I added the stuff inside the parentheses according to PEMDAS, or order of operations. Next, we want to raise the exponent. Okay, so we want to raise it to power 4. And then we want to multiply times 4,000. I'd like to show you guys the operations on screen, but it kind of takes too long. Okay. I'd rather just tell you the order. Or if you type this into a calculator exactly as it is, it'll give you the right value. Okay, so this gives us 4,118 .08519 yada yada yada. Okay, now this is money. Okay, anytime you're dealing with money, you want to be able to round to the nearest cent. Okay, nearest cent means 2 numbers after the decimal. So we're going to be looking at this value, but in order to change that value, you got to look at the one after it. If the number after the value we want to round to, in this case the cents, the hundredths place, then we got to see if the red one, the red value, is is 5 or higher. If it's 5 or higher, then the one before it goes up, meaning the yellow one goes up. So in this case, it does go up. And our answer is actually going to be equal to $4,118 with 9 cents. This is our final value. Okay, that's how much money you end up getting from this bank account for 1 year. Okay. All right. But let's go ahead and change the values around. Let's say we had something like this. You deposit $4,000 into an account that pays 2.92% annual interest rate. Find the balance after 1 year if the interest rate is compounded monthly. Okay, so these are basically the same question. You see, all I'm doing is changing one word. So I'm gonna go ahead and highlight the same stuff. We start off with $4,000. We have an annual interest rate of 2.92%. We're going to be doing it for 1 year, and it's going to be compounded monthly. Okay, there are 12 months in 1 year, so this means that it's going to compound 12 times a year. Okay. If I had said, oh, well, it's going to compound daily, well, then you might want to think, how many days are there in a year? There's 365 days, so there would be it would compound 365 times a year. Okay, if it was daily. Okay, monthly means 12, quarterly means 4 times. Now, we're gonna start off this problem just like we did before. We want to first write down our initial value. Originally, we had $4,000. We have 1 plus 0.0292. Okay, I still divided 2.92 divided by 100 to get that value. And instead of writing down 4 underneath it, because it's monthly, we're going to write down 12. For our exponent, we're still going to write down 12 instead of 4. And we're going to multiply times 1 because we only want to do this for 1 year. Okay, so now you might think, oh, well, it's the same interest rate. It's still $4,000. And it's only 1 year, right? We should probably get the same value, you would think. But that's not the case. Okay, if you compound it more times within the year, normally what's going to happen is that you're going to get more money out of it. Okay, because if you get $100 at the beginning and then it grows up to $1 in 1 day, and then you keep doing this growth over the course of a whole year, well, then you're going to end up having more money at the very end compared to getting like $7 after 1 week. Okay, it's probably not as clear to you just yet, but we'll see after we do this problem. Okay, so I'm gonna rewrite it. $4,000 stays the same. I'm gonna do the math on the inside. Okay, 1 plus 0.0292 divided by 12. Let me see. 1 plus 0.0292 divided by 12. This is roughly going to be around 1.00243, where 3 repeats. 12 to the power of 12 times 1 is 12. So we're going to leave that power there. And then we are going to calculate this value. Okay. So first we want to do the exponent. Make sure that you raise to the power of 12. And then we're going to multiply times the 4,000. You might think, oh, why am I doing this backwards? I'm not really doing this backwards. I'm just doing the operations in the right order. Okay, remember PEMDAS? Okay, PEMDAS means that you want to do parentheses first. Then you want to do exponents. Then you want to do multiplication and division. And then you want to do addition and subtraction. Normally those go from left to right. But in this case, since we don't have to add or subtract, we don't have to worry about it. Since we don't have to divide, we don't have to worry about that part. Well, we divide at the beginning inside of the parentheses, but because that's an operation in itself, we don't have to worry about it too much. Okay, so after you do all of this, you should get $4,118 with 375,922 yada yada yada. Okay, we're gonna round the same way because this is money. What colors did I use before? Oh, yellow and red. So we're going to round to this value, the second value after the decimal, and we're going to use this number to determine whether the value is going to go up or down. Okay, so everything else is going to stay the same, and then we decide whether that 7 is going to change into an 8 or if it's going to stay a 7. Well, the red one tells you it's 5. If it's 5 or greater, the number goes up. So in this case, it goes up to 8. And that's how much money you'll get from this account. Okay. Now you think, look at those values. They're almost exactly the same. They're off by only a few cents. Okay. And you might think, oh, okay, well, it's only a few cents. It doesn't matter which bank account you put your money in. But what if you had a lot more money than $4,000? Okay, well, let's say you won the lottery tomorrow and you want to put it into one of these bank accounts. Well, I don't know. I'd rather put $1 million into this account than this account. Okay. Seems like it's giving me more money. Okay. Well, let's go ahead and continue. And we'll do a few more. Okay. Let's say you deposit $2,200 into a bank account. They want you to find the balance after 4 years if your account pays 4% annual interest rate compounded quarterly. Okay. So $2,200. They want you to do this for 4 years. It pays 4%, and it's compounded quarterly. Important words right there. Okay, let's see if you remember. Okay. So answer me in the next 5 seconds. How many times does it compound in 1 year? All right, well, if you said 4 times, then you're correct. Okay, we're going to do this problem the same way we did the last one. Start off with your initial value. How much money did you have at the beginning? Well, $2,200. They said so in the problem. Inside of the parentheses, you're going to go ahead and add 1 plus your interest rate. Since it's 4%, I'm going to take 4% divided by 100. It's going to give me 0.04. Okay. It says compounded quarterly. So we're going to be dividing by 4. Quarterly means 4. Okay. And if you don't remember that, then just think of how many quarters are there in a gallon, or how many quarters are there in $1. There's 4 quarters. So it has to be 4 of them. Okay. Now, for your exponent, you always need to multiply the number that you divided by inside the parentheses. And then multiply the number of years that you're going to be doing this for, which in this case is 4. Okay. So we have $2,200. I'm going to go ahead and do the math right here. 1 plus 0.04 divided by 4, that's going to be 1.01. And 4 times 4 is equal to 16. So you want to actually want to raise this value first, meaning use the exponent first. 1.01 to the power of 16. And then you want to multiply the number in front of it, 2,200. From this, I get approximately 2579.673018 yada yada yada. It's still money, so I'm still going to be looking at this value and this value. Okay. Whoops. Great. All right. So we're gonna take our value. We're gonna round it to the nearest cent. Okay. So 2579.6, and I'm gonna change the 7 into an 8, or I'm gonna leave it as a 7, depending on what the value after the 7 is. So that red value, if it's a 5 or higher, it goes up. If it's 4 or lower, then it stays the same. Since it's less than 5, it stays the same. So we actually get $2,579.67 for this problem. That's it. That's our final answer for this problem. All right. Hopefully you have one more slide at least. Yes. Of course. You deposit $2,200 into a bank account. Find the balance after 4 years if the account pays 3% annual interest rate compounded monthly. Okay. Well, for this one, let me highlight the important stuff again. You started off with $2,200. You still want to do this for 4 years. You have 3% interest rate, and you're compounding it monthly. Okay, monthly means 12 months. Okay, so 12 months in a year. So we're going to end up dividing by 12 and then multiplying the exponent by 12. Okay, let's go ahead and write this. Original value, or initial value, multiplied times 1 plus your interest rate. In this case, your interest rate is 3%, so I'm going to take 3 and divide it by 100. That's equal to 0.03. You want to divide this value by the number of times it's going to get compounded in a year. In this case, 12. Okay. Oops. And then we're going to raise this to the power of 12 times the number of years we want to do this for, which is 4. Okay. So we have $2,200 times 1 plus 0.03 divided by 12 to the power of 12 times 4. I'm going to rewrite this. 12 times 4 is 48. 1 plus 0.03 divided by 12. That is going to be 1.0025, I believe. Let me check that real quick, just to make sure. Yep, 1.0025. Okay. Now raise the exponent first. So we want to raise that 1.0025 to the power of 48. And then multiply times the number in front of it, 2,200 in this case. Okay. What I get from here is that you're going to have 2480 with 1, 2, 1, 6, 4, 6, yada, yada, yada. Okay. We want to do our rounding to the nearest cent. Okay. And because, well, that's a 1. You can't really see that. Let me write it down again. There we go. Okay, so we want to round that 2 to see whether it stays a 2 or if it becomes a 3. Because the number after it, the one in red, is a 1, which is less than 4, less than or equal to 4. The value actually stays the same, meaning we're going to have 2480 with 12 cents. This is going to be our final value for this bank account after 4 years. Okay. All right. Now, these are better approximations of what actually happens because your money will end up growing as time goes by. So it's not just going to grow every year. It's actually going to grow every few months or every week or maybe every half year, every semester. Okay. But it could also continuously grow. Like let's say your stocks. Okay. They're not always going to grow at the same rate. Every day the values might change. But it's a good idea to keep this compounded monthly stuff in mind. Okay. Now, here's a few vocabulary words that you might want to know. And let me go ahead and write these down. Well, whenever you see the word quarterly, well, this means 4 times a year. Monthly means 12 times a year. Daily means 365 times a year, since there's 365 days in a year. Weekly means 52 times a year. That's usually a rule of thumb. If you have 52, you have 52 weeks in a year. I think 52 times 7 multiplies to 364 though, so it's a little bit off. But let's keep it at 52 anyways. Okay, it's really an assumption that we want to make. And then finally, hourly. Well, let's say your money grew every single hour. Well, you would have to take the number of days in a year, multiply times the number of hours in a day, and this is how many times a year hourly would mean. Let me go ahead and multiply that out just to make it easy for you guys if you ever see it again. Though you should know how to get to that number on your own. Okay. So 8,760 times a year is actually for hourly. Okay, since there are 8,760 hours in 1 year. Okay, now your assignment's already posted up on Microsoft Teams. Make sure that you answer it. If you have any questions about how to submit your answers, I'm trying to use Microsoft Teams now. It's gonna help me grade your assignments much quicker. Okay, so you want to submit them there, not through Remind, not through Microsoft Teams messages, just because it helps me keep track of who has turned in what, and I can still message you about whether something is right or wrong or not, so that you can change it before I put in the final value into your grade speed. Okay, I'm going to be making an Excel sheet for you guys to be able to set up meetings with me in case you need a lot of help with the work. Okay, and I'll let you guys meet up with me for as much time as you need. I just need to set up the Excel sheet. Make sure that if you're not understanding anything, please set up a meeting. I'll set up a video conference. That way you guys can get as much help as you need. Okay, that's what I'm here for. They're still paying me to be your teacher, so I want to make sure that I'm doing my job correctly. Okay. For now, I guess I'll see you guys next time. Hopefully, we'll have a meeting tomorrow. All right, be safe. See ya.